Welcome to the lecture series in computer science. We are seeing a series of lectures in the subject Python programming. In today's session, we will be seeing a topic on modules and the classification of modules. The contents of today's session are locating a module, what is a Python path variable, we will be saying how to classify the module, what are the ways of importing into a module or importing a module into the codes, into the Python program. Now, what are modules? A module is a file containing Python definitions, functions, statements and instructions. Standard library of Python is extended as modules. To use these modules in a program, the programmer needs to import the module. My dear viewers, you would have seen in the other languages to work with, for example, if you have worked with the languages of C or C++, you would have used hash include and the header file. Similarly, here in Python, if you want to use a particular function, a module, you import. There in the other languages you have used hash include conio.h, hash include stdio.h, hash include math.h. So, here you import that mathematical module. So, here, so that is the reason we are saying it as we are supposed to use import the module. Now, we will say how to import the module. Once we import a module, we can reference or use to any of its functions or variables in our code. There is a large number of standard modules available in Python programming. Standard modules can be imported the same way as we import our user defined modules. Every module contains many different functions. To access one of the function, the name of the module has to be specified and the name of the function has to be separated by a dot, and that is the reason this format is called as the dot notation. My dear viewers, this is a very important interview point of view question as well as the examination point of view question. When you are going to import a module and when you are going to use it in the name of a function, it should be separated by a dot and it is called as the dot notation. The syntax for a module is import module name, and my dear viewers, kindly make a note of it. As I have said in the earlier lectures, Python is case sensitive. This import is different from capital import. So, you are supposed to give it as a lower case, small letters, import and a module name. Module name, so when you want to use it in a function, as I said, you have a dot operator, the dot notation, it is module name dot the function name bracket the arguments, the variables. So, this is how you import a module. Now, let us first of all locate the module, where the module is. How do you locate the module? When the module is imported, the Python interpreter searches for the module. It searches in the following sequence. First of all, it will search in the directory where you have stored your scripting programs, where you have stored your scripts, where you have stored your codes. So, that directory will be stored, the current directory will be stored. Second, if the module is not found in the current directory, Python then searches each directory in the shell variable Python path. You are supposed to create a shell variable Python path during installation. By default, the Python path will be the directory that is wherein your Python shell has been located. So, by default it will be the directory, or if you have a current directory, it will be searching in the current directory. If it is not found in the current directory, it will be searching in the directory in the shell variable Python path. Even if the module is not available in the Python path, where will it search then? If everything else fails, Python checks the default path. On Unix, the default path is, it will be normally it will be /user /local/lib/python. It is /user /local/lib/python. The module search path is stored in the system module sys as the sys.path variable. The variable name will be written as sys.path variable. The sys.path variable contains the current directory Python path and the installation dependent default. By default, you have this Python path. If you want to set it in a different location, you can set like this, as we could see in this slide. The Python path, what is a Python path? And my dear viewers, as a question for this particular slide, how do you locate the modules? What are the sequence in which the interpreter will search? So, it will search in 3 different places. One is, it will search in the current directory. If it is not found in the current directory, it will search in the Python shell variable Python path. If it is not found in the Python path, it will search in the default path. So, these are the 3 locations wherein the modules will be searched. So, it is a prominent question that could be asked in the examinations. Now, what is a Python path variable? A Python path, it is an environment variable. A Python path is an environment variable consisting of a list of directories. It consists of lists of directories. The syntax of Python path is the same as that of the shell variable path. Now, how do you set the Python path for a Windows operating system? Python path for a Windows operating system is set as in the command prompt, not in the Python shell. You are supposed to set it in the command prompt by pressing Window R button, type as cmd, press and enter, you get a command prompt. In the command prompt, in your Python directory, you type it as set Python path, it is case sensitive, Python path equal to /python, say for example whatever name, folder name you have, /lib. Lib denotes library. Put a semicolon, press and enter, your Python path will be set. If you are going to use the Unix operating system, you are supposed to set it as set Python path equal to /user. In Unix, the user name is written as usr, user /local/lib/python. So, this is how you set in a Unix operating system. Now, after setting the Python path, after importing the module, now let us see what are the different types of modules that are available. The modules are broadly classified into 2 types. One is called as a built-in module, second one is called as a user-defined module. User-defined module is a module which has been created by the user and he can use that particular set of codes for future programming, and he can import that particular set of codes for his future codes. That is said to be a user defined module. Now, by default Python language provides few different modules. Such a module you call it as a built-in module. For example, math. Math is a built-in module which contains all the mathematical functions. Similarly, in your C programming, you had math.h, hash include math.h. It is a mathematical module. But here in Python, you have more and more functions when compared to the other languages, C language. And my dear viewers, few people might be saying, sir, I am highly comfortable in working with C language, but I am brand new to Python coding. But I know in and out of C language, I do not know Python. How do I work? Can I use my C codes in Python? My dear viewers, for working the C codes in Python, you have a separate language called as Python. Python is a combination of C and Python. Few people might be saying, sir, I am highly comfortable working with Java, but I am brand new to this Python world. How do I do my coding? For which, if you are so comfortable with Java, you can integrate, you can take all your codes, you can put it in Python, and that language called as Jython, which is nothing but Jython. Jython denotes Java plus Python. This Jython language is a combination of Java plus Python. Python language is a combination of C and Python. When you want to browse more details about the Jython, you can refer the website called www.cython.org for C and Python, or if you want to work with this Jython language, you can refer it as www.jython.org, which has a combination of Java and Python put together, and it is an exclusive language that has been used over there. So now, since we are concentrating on this Python, we will see exclusively about the built-in modules present in this Python. Why I referred with Python and Jython is you can use the same built-in module even in Python or in Jython too. So let us see about this Python. Now you have one of the built-in module called as math. Math is a mathematical module which has all the mathematical functions. So when you want to use the module, what is the syntax that we seen in the previous slides? It is the module name dot the function name. Module name dot the built-in function name. It is a built-in module name, so dot the built-in function name. So built-in module name was said to be math dot built-in function name is said to be ceil of x as a variable. Module name dot function name bracket variable, which returns the ceiling of x, the smallest integer greater than or equal to x. Now the other function is math dot floor of x. When it returns in ceil returns the ceiling, this floor returns the floor value, returns the floor of x, the largest of the integer less than or equal to the x value. Largest in the sense whatever value that you provide within this x, that will be printed. Math dot factorial of x, it will return the factorial of x, x factorial. My dear viewers, in other languages such as C or C++, you would have written a lengthy coding for finding the factorial of a number, and that is the reason in my earlier lectures I have said Python coding is 10 times less when compared to C coding, 3 to 5 times less when compared to the Java coding. So you have, for anything and everything, you have the built-in functions available. You just need to import, you just need to plug and play and just execute it. That is the specialty of Python. So math dot factorial of x will return the factorial of the particular value. For example, if I am going to give it as math dot factorial of 5, math dot factorial of 5, if I am going to type in the chevron, it will return the value of 120. Similarly, math dot gcd of x comma y, gcd denotes greatest common divisor, it returns the greatest common divisor of the integers of a and b, wherein for these things you will be writing a very lengthy coding in the other languages, but it is not the case with respect to this Python language. Math dot square root of x, it returns the square root of x. Math dot log of x returns the natural logarithm of x. Then how will I return the base 10 and base 2, for which you are supposed to write it as math dot log 10 of x. Log 10 of x returns the base 10 logarithms. Math dot log 2 of x, it returns the base 2 logarithms of x. Math dot sine of x, it returns the sine value, sine of x radians. Math dot cos of x, it returns the cosine value of cosine of x radians, math dot tan of x, it returns the tangent of x radians. All these three things will be using it in trigonometry, mathematical calculations in trigonometry, we will be using it. Math.pi, it returns the pi value. Here you have the pi value, it returns the pi value, the mathematical constant pi. What is the mathematical constant pi? It is 3.141592, it goes on. Now math.e, it returns the mathematical constant E value. Mathematical constant E is represented as 2.718281 and so on. So these are the built-in modules. Now let us see the second built-in module, random. What is it, random? It generates pseudo random numbers. Pseudo denotes false, false random numbers. Some sort of random number generation, when you take some sort of counseling, random numbers are generated. It is how it is generated. So to generate pseudo random numbers, we use random built-in function. Random dot rand range of stop, which means this random is a module name, this is rand range is a built-in function name, stop is a variable name. Stop is till which number I need to take the random number, that is a variable name. We will see examples with respect to this. Random dot rand range start comma stop, which means if I am going to give it as 10 comma 25, press and enter, you will get a random value between 10 and 25. Any value that the computer will give as an output, that is called as random dot rand range of start comma stop. Then random dot uniform of a comma b, what does it denote? It will return a random floating point number within a given range. A comma b, again if you are going to give it as 10 comma 25, within 10 and 25 it will return a floating point number. That is how we write it as random dot uniform of a comma b. Now let us see how to import the module name, how to import the function, how to correlate with the module name with as a, if it is of a built-in module, and if it is of a user defined module, how do you do it? We will see with the comparative statement. As far as the built-in module is concerned, you have import math, math is a built-in module, import math, x equal to math dot square root of 25, print x. When you press and enter, what is the answer that you get? You get the square root of 25. What is the square root of 25? It is 5. The result will be printed as 5. So here it is a module name, here x equal to math dot square root of 25, print of x. As again my dear viewers, you can give x space equal space math dot square root of 25, print x, so that you have a coding clarity. So it will be printing 5. Now this is with respect to built-in module. With respect to user defined module, import cal. What is this cal? If I had already written a program function called cal, if I have stored it in my current directory as cal.py, then I can import this function cal, x is a variable name, equal to cal.add of 5 comma 4, print x. What will happen? If I had a program, function program by name cal, and if I had written the addition program as something like c equal to a plus b, wherein a is 5 and b is 4, 5 plus b 4 will become 9. So when I print x, it will be returning the value as 9. So this is how a user defined module is written. If it is a built-in module is imported like this, a user defined module, it is imported like this. In both the cases, the Python, ideally the Python shell will recognize, will check whether it is a user defined module or whether it is a built-in module. If it is a built-in module, it will take, if it is a user defined module, it will check the current directory or it will check the path from the Python path. Now, let us see the different ways of importing a module. There are 4 different ways to import within a Python module. First is the generic import. It is the simplest and the direct way to use the modules, as we have seen in the previous example. Second one is from import. You can import, say for example, you have written a very lengthy code and you have stored it in some place, and you want to use only one function from the very lengthy code that you have already stored. So, you can use from import this particular module in which this particular function. It is used to retrieve a specific function of a code from a lengthy code which you have already stored it in some directory. The third way of importing a module is import with renaming. Supposing if I have written a very lengthy code, I have saved it with a very lengthy name as some name of a very lengthy environment variable name, so on. This is useful. I can just like that I can rename with a single character or with a desired name. The modules, it can be renamed for importing. That is called as import with renaming. The fourth way of importing a module is import all. Import all, that is all the definitions of the module are imported using a star key. When you press a star key, when you give import all, whatever definition that is available within that module, anything and everything that is available in the module will be imported. So, that is called import all. My dear viewers, the question for this is an important entry point of a question, that is, what are the ways in which the modules are imported, or list the 4 different ways of importing a module. One is import, the generic import. Second one is by using from keyword, from import. Third one is by using import with renaming. Fourth one is import all. Now, here when you see from import, it is something like this. From, as I said, Python is case sensitive. So, this from was different from this from. So, you are supposed to use only lower case. Now, let us see a generic example, as we have seen a direct import. This import math, you take a variable x equal to math.py. What is that py? Py is nothing but pi value. You have seen a pi value. When you say math.py, py will hold a pi value. Pi value is 3.1415926535897993. It goes on. So, when you print value of pi is x, what happens? From this particular mathematical module, this particular built-in function will be called. This particular built-in function pi will hold the value of 3.1415 so on. When it has been printed, value of pi has been printed with a variable x, you will be getting the result as 3.14159265 so on and so forth. This is an example for a direct import. Now, let us use the second way of importing from math import pi. X equal to pi, print value of pi is x, the value is printed. What is the difference between the previous program and this program? In my previous program, I have imported all the functionalities of the math module and I am using only the functionality pi. I am calling the functionality pi and I am storing it in this x. Whereas here in the second case, I am taking only the functionality pi from the lengthy module math. In math you have ceil, you have floor, you have GCD, you have ways to compute the factorial, you have so many functions, wherein I am calling only the pi function and I am using it. So that is the reason I am writing it as from math. From where? From math. Math is a module. From the math module you import only pi. What does it mean? From the math module only the pi function has been imported, and after I import I store it in a variable called x, because pi holds the value of 3.1415 so on. I store it in a variable called x, x equal to pi. I print the value of pi as x, press and enter, the value is printed. This is how we import from import. Then renaming the import, import all, renaming import, import math as G. As my name is Ganesh, I just give it as G, import math as G, x equal to G dot pi, wherein I have renamed the math by itself as G dot pi, print the value of pi as x. So again the value is printed. Now import all, from math import star, whatever functions that are available within the math module, anything and everything that is available within the math module will be imported. X equal to pi, print the value of pi x, so the value of pi will be printed. So I am importing all, from math import star denotes whatever values, whatever functions, whatever definitions available within the module will be imported. So then let us see an example to find the distance between any 2 points. Here it is, import math, x1 equal to int input of x1, y1 equal to int input enter y1, x2 int input enter x2, y2 int input enter y2. Now the distance, if you want to calculate the distance, what is the formula? Square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, that is the formula for finding the distance. So we have got the inputs, so we use the mathematical module in which the built-in function square root of x1 x2 x1 y1 x2 y2 values we have obtained. So x2 minus x1 the whole square, this denotes the exponential, plus y2 minus y1 the whole square, this denotes the exponential. I print the distance. So when I print the distance, when I press and enter, enter x1 7, y1 6, x2 5, y2 7. When you compute, you get the result as 2.5. So this is how you print the, you find the distance between any 2 points. Now let us see an example for the random module. In the random module example, we saw about the rand range function, uniform function, and just rand range of start and stop value. So we import random, x equal to random dot rand range of 34, I just print x. What does it mean? You print a value which is less than or equal to 34. So randomly a value of 14 is printed, which is randomly printed by the computer. Second example, x equal to random dot rand range of 34 comma 45. This is said to be the start, and this 40 is said to be the stop. Here what happens? So from between 34 and 45 some value will be printed. When I print x, just 41 will be printed. Now if I take over here and place the cursor over here, press and enter, the values will be, the code will be printed. So x equal to random dot uniform of 25 comma 34, print x, some value, some floating point value will be printed, 25.33. If I press again, another value will get printed. So these are the examples for the random module example. Now let us summarize this session. We saw about how to locate a module, we saw about what a Python path variable is, how to set the Python path variable, we classified the modules, classifications of module, we saw the different ways of importing a module with varied examples. Thank you.